Rochelle, what'd you do first? Shh. Yell. What is your p-value? Shh. Okay, tell me all the factors of 54. 27, 9. Put them out of order. 6. 54. Any others? Class, any others? 18. And your key value, Rochelle? 4. Factors of 4? 1, 2, 6. Okay, so these are all the numbers we can test. Let's make it super obvious. Rochelle, I want you to list out all of the possible positive numbers or rational zeros we can get. 54 over what? Is that divisible? I don't know. Just 3 halves. 19 over 2. 9 over 2. And that one reduces to 27 over 2. Alright, so those are all the ones you could test, both positive and negative, right? Lots of numbers to test. Diana, what number did you pick? Nine? Positive or negative? Diana, tell me what numbers are right. Alright, Diana, do it. You're adding those, right?
Yeah. Only one. And then remember the
How much?
35.91.
35.91. 36.36. 32. 72. 4. 32, 6.
7.
Diana. No what? No more? No what? Do you have a remainder? Is this a factor? No. So don't pick positive 9. Diana, do you know a number that does work?
Negative 2.
-2? Charlotte, do -2. So no, not factor. Alright, Charlotte, give me all the numbers. You gotta shout at me. Oh, that's supposed to be 54. 0. Raise your hand if you got that so far. -2 works? Okay. So -2 works. Okay, let's keep using this idea of the rational roots theorem. I know that this is 1 degree less than what we started with, so this is going to be 4x to the third. But if you keep using the rational roots theorem, this keeps going down. Does that make sense? The degrees keep going down. So let's do that together. Damien, what other number do you want to test? You're sure 6. Do you like talking in front of the class? Okay, so you sure you want to use 6? What did you say? 27?
6 or 27.
So are you just randomly picking one of these numbers? Is there a faster way of checking if those will work or not? Oh, we're graphing the function. So if I graph the function, do you graph it? Damien, look at this. Does this give you any ideas of what you could be picking? Does this graph give you any ideas of where to start? What number is this, Damien? -2. What is this number? A fraction. What fraction do you think it is? Close to 1. 3/4. Let's test 3/4, Damien. Damien, 3/4 times 4. Add. Multiply. Add. 3/4 times 36 over 1. So 3 times 36 divided by 4. Or cross cancel your 4s. Add. 0. Alright. Let's go back and figure out what this means. What does this one mean for us? Jocelyn. X plus 2. Jocelyn, this one? 4x minus minus 3. And what does this mean?
That's 4x squared plus 3.
Class, is that factorable? No. Okay, what do we do next? Partner A tell partner B, what do we do next? Pablo. What do I do? Okay. If I set each of these equal to 0, and this is kind of redundant because we already know that x equals what value class? -2 from back up here, right? We already knew that. Class, this one's going to equal what? 3/4. Pablo, let's solve for this one. What do you want to do? Keep going. Divide by 4. What do you get? -9. Keep going. It's your birthday. Yes, Pablo. Keep going. Everyone talk to your partner. 10 seconds, go. What would you do? How do you solve that? Tell them what pirates say. What do pirates say? Class, what do pirates say? Aye, matey. I. Class, what is I? I is the square root of -1. Class, what is the square root of -1? What do pirates say? Say R and get it wrong on your test. And then the square root of 9 is 3. So x equals plus or minus 3i. All right. Real or complex? Real or complex? Real or complex? So 2 reals plus 2 complex, right? It's 3i and -3i equals how many? 4. This should be a hint because 4 is way back up here. The fundamental theorem of algebra. The max number of zeros is going to be 4. In this case, there are 2 reals and 2 complex. Okay? So notice here I just kept using rational roots theorem and synthetic division to keep bringing down the power of the polynomial. In this case, we actually didn't have to use Xbox factoring, and then you guys just had to solve the complex knowing that pirates say what? Aye.